Welcome, everyone. We will begin the webinar on Metal Panel and Weld Bond Best Practices, ICAR training presented by Norton St. Gobain. I'm Melissa Jolls with RDA Impact, and Craig Chaffee, the training manager for Norton St. Gobain, is your presenter for this webinar. The presentation will take approximately 55 minutes, and we are recording it and we'll post it on the YouTube channel. If you do have questions during the webinar, you can type them in the chat box at the bottom right of your screen, and Craig will answer those at the end of the presentation. Craig will also explain what you will need to do in order to get the 2 ICAR credits on Metal Panel and Weld Bond, and I will follow up with everyone on the call, and I will be sending you the information along with Craig's contact information. Now I'll turn it over to Craig.
Thank you, Melissa. Welcome, everybody. Appreciate Impact Collision and Solutions being our host today. And as she mentioned, we're going to go over metal bonding and weld bonding best practices. If you're unaware, we've been part of ASE, the Continued Automotive Service Education training provider, since 2008, and we've been part of the ICAR Training Alliance since 2008. I will go over the classes that are available besides this one in case anybody needs any additional training. I'll also show you how to apply for your 2 hours of credit, even though we're going to be together for an hour, and even show you the test if you're interested at the end, how you can go about getting credit for those particular credits, because I know it's the end of their fiscal year and people are trying to get their 6 hours, even though we can take care of 2 hours today. So first and foremost, obviously we got to get the old panel off, so we have to remove it however it's necessary. I know you have the variety of tools in your particular shops out there, your air chisels, your grinding, your cutting. And the biggest thing that we want to look for is make sure that the substrate that we're going to glue the new panel onto is straight. And so there's a picture here of some hammering and dolling. And obviously the objective here is to make sure that the new panel fits the existing portion of the vehicle that we're deciding to leave on the car, depending on what the OEM tells you you can cut in and out. And we'll even talk about that near the end of this presentation, of where you should weld and where you should glue according to the OEMs in terms of best practices. So once we get the new panel, the old panel off, then we need to go ahead and clean the bond area. We do have a panel and adhesive cleaner. It is a solvent-based product. Obviously don't want to use a waterborne cleaner here, because if we're dealing with any metals, then we're going to promote rust. So it comes in a quart can, and I know there's some others out there, but the big thing is we want to make sure it's solvent-based so that it flashes off and evaporates on the actual bare metal, because we want to get down to bare metal when we're talking about metal bonding. And the same thing with weld bonding, because we're going to get the best adhesion and connectivity with the welder if we're down to bare metal, so in a nice clean surface. So just like any other type of refinishing, the cleaner we have the substrate, the better attachment of anything we're going to have, either glue, weld, refinishing, painting materials. So, and also helps eliminate any contaminants in the bonding area that might have been there previously. So once we get the old panel off and we clean it, then we're going to have to do some grinding. This is an actual picture from the video that I'm going to show you in a few minutes. 36 grit seems to work out very well, and the reason for that is it removes any paint and corrosion, but it also establishes a tooth for the adhesive. It's no different than if you're working with body filler. Body fillers require a certain tooth. Usually they're in the 36 to 80 grit range. It's the same thing here with glue. Obviously the coarser the better, the more tooth we're going to get. We're also going to talk about panels that require welding. So if you're doing some welding and it calls out for a weld-through primer, we do have a zinc-rich weld-through primer to help with corrosion protection. And we'll talk about some of the areas that the OEMs tell you that you need to weld. For example, we'll talk about on a hood, the 4 corners, the OEMs tell you need to weld there. So those particular areas should be primed first with a weld-through primer. We picked zinc-rich for a couple of reasons. We think it's the best corrosion protection. Also, there's some various opinions out there about copper. Nothing against copper, but ICAR I don't think is a big fan of the copper ones, even though it's got really good conductivity. it might not have the best corrosion protection. So we've had zinc for a number of years, and it seems to work out pretty well. It is an etching primer, so you'll see that you don't want to get any adhesive, and you want to remove this primer if it becomes in an area where some top coat is going to be applied, because it's a physical etching primer. It's designed specifically to be welded through and to protect the bare metal in that particular area during and after and before you actually do any welding. So as you can see there, the objective is corrosion protection to keep the areas that are going to be welded. 3-inch disc seems to work out pretty well, so you'll see some part numbers there for one of our most popular 3-inch 36 grit discs. These are the orange discs that a lot of people might have seen throughout the marketplace. And then, of course, the proper backup pad always works out well. A 3-inch disc should use a 3-inch backup pad for safety reasons. I know there are some folks that might put it on a 2-inch because they like to bend it over. The good thing is both are recommended for 20,000 RPMs. So, but the proper backup pad definitely helps, makes the disc last longer, and just for a safety standpoint is a better idea. And then there's a picture of the weld-through primer. It comes in a spray can like some of the other weld-through primers that are out there. Once we're grinding, we want to do a dry fit. Matter of fact, you'll see in the video there's a close-up picture of a Clico, but we'll talk about other clamps. You'll even see Peter, our friend from Dream Car Garage and Legendary Motor, the show that we sponsor. You'll see him use these Clicos. He also uses them as an alignment pin because he's actually going to do a pretty neat aluminum door skin on a metal door frame. And I won't steal too much of his thunder, but you'll see that in the video in a little bit here. So obviously the idea of the dry fit is to make sure we get the proper fit before we put the glue on, because Peter will even mention in the video we really only can do this once. Once we put the glue on and the two panels come in contact with each other, we can slide it into place, but we really can't pull it back off. If we pull it back off, we're going to have to start all over again. One good thing is that panel and adhesive remover does do a really good job in removing any glue that you don't want there. That for some reason that would be the case if you had to start all over again. But the dry fit is really to make sure that the new panel fits the substrate and everything where we want it to go properly. Once we dry fit it and we actually apply the adhesive, we have a couple of options. We're pretty proud of the fact that we have urethanes, acrylics, and epoxies. Urethanes we've talked about in some of the other classes that we've done with our friends at Impact. We primarily recommend those for plastics. They're very strong, but they're not so great for corrosion protection. And that's why they're great for plastic, because plastic typically doesn't corrode or rust. So what we want to do, depending on the adhesive that we pick, we want to apply it along the bond line, on the vehicle, and on the new panel. We want to brush it out to make sure that we cover all the bare metal where we've ground. And I keep alluding to the video, but Peter does a nice job showing the actual, this is a picture right from the video, applying the actual adhesive. And obviously, as we talked about it in the previous slide, we don't want to apply the adhesive where the zinc-rich weld-through primer is applied. And just the point that I mentioned earlier, once the panels are glued together, they should not be pulled apart, because then you'll break the bond. But you can slide it into place. And obviously, the objective here is to make sure we get 100% coverage for both strength and corrosion protection. So you'll see a couple of adhesives listed here. Acrylics have become very popular. The OEMs like them for a number of reasons. They have the best corrosion protection on the planet. They can also be resistant spot welded through, not MIG welded, but resistant spot welded through. And they are actually stronger than epoxies. You'll also notice we do list 2 epoxies here. Epoxies are pretty popular. They're pretty user-friendly. The big thing with an epoxy, though, is it can't be resistant spot welded through at all, where an acrylic can be at anywhere throughout the process. Actually, I'm sorry, the epoxy can be welded only in its wet state, where the acrylic can be done throughout the process, preferably in its wet state. But the neat thing is say somebody puts a quarter panel on at night and realizes, oh, I didn't do the taillight section, or I didn't do where the new panel meets the old panel. The neat thing about acrylic is it can be resistant spot weld through at any time during the repair, where an epoxy cannot. Once it's dry, unfortunately, you have a very high probability that it's going to catch on fire. It's usually on most of everybody's labels that epoxy should be resistant spot welded through, not MIG welded. Nothing on this planet can be MIG welded through in terms of an adhesive, but an epoxy should be done in its wet state. And then, of course, there's applicator guns out there for the respective products, and mixing tips are the best way to go. We do have a help tech line that you'll see, I believe, at the end of the presentation, and I can tell you a number of people have called and said, geez, the glue didn't mix right. Well, did you use a mixing tip? Well, no. That tip is designed to make those two adhesives mix properly, much better than you could ever do on a piece of cardboard, which you're not supposed to do anyways, or on an onion sheet or a mixing board. So the tip is very critical. It's very little amount of material, but you're going to get the most proper usage. So you've got a couple options there, and you can see the different cure times. So obviously 45 minutes is pretty good for doing a door skin. 75 minutes is pretty good for doing a quarter panel. 90 minutes really good for doing a big van side or roof skin. So you've got some time there depending on how big of a job that you need to metal bond or weld bond, and we'll talk about the combination of the two in a little bit here. So once we apply the adhesive along the bond line, we actually are going to apply another bead of material. And the reason for that is to make sure that we get proper adhesion between the old panel and the substrate, and we actually get some squeeze out or ooze out. This way we know both panels have come in contact. The neat thing about all these adhesives that are listed here, they have what they call glass beads in them, so you cannot over clamp it. So we want some ooze out knowing that the glass beads are in there, and it'll stop you from over clamping, so it's physically impossible to push out all the glue. But ooze out is a good thing to know that we have full contact with the new panel and the substrate or the area that we want it attached to the vehicle. So we reapply a bead of glue, as it says here, about half the size of the bond line, and you'll see that very well in the video. Where the glue has already been brushed out. The reason for that is it allows the glass beads to do what it needs to do, but it also guarantees 100% contact between the two panels. Because just to give you an idea in strength, when we're talking about an acrylic, it's around 3,000 pounds per square inch tensile strength. An epoxy is about 2,000 pounds per square inch tensile strength, which is about the same strength as a spot weld. So you can see why acrylics are becoming popular. They're stronger than a spot weld, but also you can resistant spot weld through at any time during the process. So more and more OEMs are calling for an acrylic adhesive in addition to an epoxy. Even the F-150s are approved with the aluminum for both an epoxy and an acrylic, depending on the application and the job that you're doing. So once we apply the adhesive, we clamp it into place. Screws can be used too, whatever your preference is, but the big thing is we want to hold it in place long enough for the glue to cure. Most of the adhesives, I know ours for sure, have the clamp time right on the front. So for example, a 90-minute glue might call for 4 hours of clamping time. That allows the adhesive to set up. If you screw it into place, then obviously it's going to be held there all along. If you resistant spot weld it, it's going to be held into place long enough for the glue to dry. So we want to clamp or screw the panel into place for the traditional bond. If you're using a resistance welder, we talked about this. The advantage of an acrylic, it can be either wet or dry, but you can also only do resistance spot welding with an epoxy when it's in its wet state. Okay, and you'll also notice that if you're using any other type of welder, specifically maybe a MIG welder, then you don't want to get within 2 inches of the adhesive. As I mentioned, the epoxy will catch on fire. The acrylic, if it's too powerful, you could burn away the acrylic, but most resistant spot welders will be just fine. After the recommended clamping time has passed, you can remove the clamps. You can remove any of the excess glue with a rapid strip disc, or if it's not fully cured, you can clean it off with the panel adhesive cleaner. And there's a note here that full cure time is different than clamp time. For example, another advantage of an acrylic is no matter the temperature, it's going to take 8 hours to cure, where a 90-minute epoxy is 24 hours. And the reason that I bring that up is if a shop decides to do a quarter panel, a door skin at 5 o'clock, say today, or have it done by 5 o'clock today, 24 hours is 5 o'clock tomorrow afternoon, not 8 o'clock tomorrow morning. Now, if it was an acrylic, then I could move that vehicle, take care of that panel much sooner because the cure time is 8 hours, no matter the temperature. Now, can I accelerate an epoxy? Sure. And the typical rule of thumb is for every 20 degrees I increase in temperature, I cut the time in half. So all glue cure times are based at 70 degrees Fahrenheit or 21 C for our friends in Canada, or that are used to Celsius. So if I'm in a, say, 90-degree day or a 90-degree shop, then my 24-hour cure time at 90 degrees, if it's panel temperature and it's constant, has now just been cut to 12. So you can accelerate the cure time with an epoxy, but the acrylics, no matter what the temperature is 8 hours because it's just got to do what it's got to do. Okay, and the objective here is to allow the adhesive to build up the proper tensile strength, because the longer you give the glue the chance to dry, the better strength you have and the more corrosion protection you have. And there's a couple of different products there listed on how you can remove. The little pictures of the vehicles we'll go over in a minute with a little more detail on where the OEMs say that you can weld and where the OEMs say that you can glue. So these are some generic pictures that we'll go over in more detail. And if anybody's interested in taking the test, there's some questions on there on where you can weld and where you can glue according to the OEMs. So for example, a quarter panel, all the OEMs ask the collision industry to weld the taillight. And the reason for that is they have crumple zones that, as the strength that I mentioned, if they weld the taillight, it's about 2,000 pounds per square inch tensile strength. If they glued the taillight with, say, an acrylic, then it's stronger than the original weld when the car was put together. Then the passenger inside is going to absorb more energy than if they welded it. So there are certain crumple zones that they put into the vehicle that they want specifically welded, the taillight being one of them, and also where the new panel meets the old panel. They want these areas to physically break so that those areas take the impact, take the energy, and it doesn't get transferred into the passengers of the vehicle. But you'll notice you can glue everywhere in between. So you can glue down the bottom of the panel, around the wheel well, all the way up and back towards the taillight. And the reason for that is because that's what the OEM is calling for. They want the weld to take the impact. Matter of fact, there's only one manufacturer that I'm aware of on the planet that will not let you use adhesives, and that's Toyota. They want everything welded. But all the other manufacturers will specify an approved glue, and it's typically an epoxy or an acrylic. So that blue line represents everywhere you can glue, and all of the OEMs recommend that you weld the taillight and where the old panel meets the new panel. If we get into some larger trucks, so if we're doing the inside of a pickup truck box side, the OEM wants you to do the taillight area. They also want you to do where the inner panel meets the floor bed. Once again, they want these areas to break to absorb the energy instead of the passenger inside. So you notice you can still glue around the wheel well, you can still glue the top of the inner panel, but they still want you to weld the taillight and to the base or the bed of the truck on the inside. When we look at the outside, pretty much all they want you to do is weld the taillight, and once again, everything else, even the bottom, even though it's not lined blue, can be glued with an adhesive. But once again, they want the taillight to absorb the energy, not the passenger or passengers inside. So just to go back, on an inner panel, they want you to weld it down to the bed, floor, and then on an outer panel, you just got to do the taillight. Everything else can be glued. If we look at minivans, or sport utility vehicles, once again, they want that taillight area to be welded to break and absorb most of the energy. Now, if the passenger inside, you notice everything else can be glued, even around the gas cap. area. So the philosophy is still somewhat the same with the van side, just obviously a bigger area. So this is typically where a 90-minute glue might come into play as opposed to a 45 or a 75. Could you still do a van side or your sport utility vehicle with a 75? Sure, it just depends on how good the technician is and how efficiently they prep and get everything to go. When we look at, and I mentioned this earlier, when we look at a roof panel, the OEM wants you to tack the corners into place, but everywhere in between can be glued. So a 75-minute or a 90-minute glue, either an acrylic or an epoxy, can be used. Obviously, the advantage of the acrylic, as I mentioned, can be welded through at any time during the repair. So if I got glue in the corners where I had to tack weld it, if it's an acrylic, I'm fine. If I use an epoxy, I better do it when it's in its wet state or stay away from the glue by a couple of inches, if possible. And this is, once again, most OEMs recommend this. A door skin application doesn't require any welding. Of course, it could be crimped over the glue, as most of you probably know, but the entire door skin can be glued. Matter of fact, the video that I'm about to show you is about 8 minutes long, and it's Peter doing an actual door skin. He's doing an aluminum door skin over a metal door frame. So you can definitely do aluminum to metal with an acrylic or an epoxy, and we've talked about the benefits and advantages of each one. So speaking of the video, it's on our website, nortonautomotive.com. We also have a YouTube site. You can also follow us on Twitter or Facebook. And if you have any questions after the webinar or you're using any of our products, Dennis Beardsley, our technical trainer that works for me, answers that line as best he can. If you don't catch him, leave a message and he'll get back to you as soon as he can, but he can answer any questions on the glue. He's also a fellow part-time ICAR instructor like myself. So the video is on our website. It's on a number of places. We have a number of best practice videos. This one in particular is our longest because it is in regards to metal bonding and weld bonding. So I'm going to show you the video because that's the end of the presentation. So let me pull up the video. And like I said, this is Peter Klutz. If you're unfamiliar, he used to host a show called Dream Car Garage that we sponsor. Now that was on the Discovery Channel. Now he's on the Velocity Channel with a new show called Legendary Motor. And this was actually done up in his shop in Toronto, Canada.
The coolest, most expensive Camaro ever built was a '69 ZL1. During the peak, they were almost $1 million. Today, they're still $500,000. They only built 69. Well, one of our good customers asked us if we could do some aluminum panels for a ZL1 clone. So we're actually made some aluminum door skins that we're going to bond to this steel frame here. We've got some neat products. This is best practices for panel adhesion. Doesn't matter if it's aluminum or steel, the process is the same. Well, the first step is to make sure that both panels are nice and clean, but you don't want to ever mix up the disc. We're going to start with a 50 grit on the steel. Now you want to make sure that you switch out the discs because you're never going to mix an aluminum and a steel grinding disc. This one we're going to go with an 80 grit. Once you're finished that, you're just going to blow off the panels. Now we're ready to test fit it. What we're going to do is do it first dry, make sure that everything fits right. cleat-close. Once we've done a dry run, we'll take the panel back off, blow it off one more time, and then we're ready to apply the acrylic metal bonding adhesive, and we're good to go. With this door skin application, Norton's got two products. They've got a 45 and 75 minute metal bonding product, which is an acrylic, and then for just about everything else, they got a 90-minute epoxy bonding. It'll do just about anything. Either one of these, the application is roughly the same. Well, the acrylic metal bonder has great corrosion-resistant properties, but you're going to want to put on a set of latex gloves. The problem is, it also sticks to your hands really well. Here at Legendary, we do full physicals before you start. Now you're going to purge the system again. Oh, came out fast. Make sure it's coming out equally. Once you're sure of that, you're going to screw on the applicator. You're also going to make sure it's coming out even. There we go. Once we've got color, we're good to go. Now we're going to lay a bead along the entire panel edge. You're going to want to work around both panels. It doesn't have to be a heavy bead. You're going to want to do the same on the door skin. Just a nice uniform bead all the way down. Then your next step is you're going to take an acid brush. Just start wiping it. Making sure we got good coverage right to the edge. The nice part of either one of these systems is you have some time. This is a 45-minute system. You also have a 75-minute system if you're doing a bigger panel. Just going to make sure, because this thing is a great corrosion-resistant product, you want to make sure that you cover all of the bare metal with the material. The other nice thing about this material is it's a weld-through material. So if you wanted to weld it as well, you're more than capable of doing it with it. The extra 10 seconds it takes to go over it twice, just make sure that this thing doesn't, especially bonding aluminum and steel, you want to make sure it's covered nicely. Then what you're going to do is lay one more bead around the door frame edge. We're just going to make sure that we got a nice bead along here, just so we have some clamping pressure. All right, we're ready to go. So now, we've got some time, but you can't apply it twice. You can move it around, but you can't lift it and break the bond. We're going to grab the panel. Try and get this as right as we can. We're going to just put the cleat in. We'll use that to hold it initially. Once once all the clecos are in, we're going to use now some vice grips basically. The other nice thing about this product is you can't over clamp it. It's got glass beads in it that keep it at the correct distance. What you're going to do is wipe off the excess, because the excess will never get hard. The only time it bonds is that when it's between two pieces of metal that have been sanded to, somewhere between 30 and 80 grit. So if the edges aren't 100% dry after, a couple hours, then don't worry about it. Just wipe off the excess. And the important part is in between the two pieces of metal. It's rock solid. So after an hour and a half, you can take off the clamps. After 8 hours, it's fully cured. That's best practices for metal bonding.
So a couple points that I want to bring out there. Peter did talk about the nature of an acrylic. It doesn't get hard unless it's trapped between two pieces of metal. So believe me, since we've launched this product, which you can see the video dates back to 2011, we've received a number of calls, and there are some other acrylics out there that people will say, well, it doesn't seem to be hard on the ooze out. Well, the ooze out, as he said, doesn't matter. It's what's in between the two pieces of metal. The adhesive actually starves itself of air, and that's how it dries. So that's the neat nature of the acrylic, is it's only going to get hard in between the two pieces of metal. It technically becomes one with the metal. And as I mentioned, if you have any other questions, we have our tech line that's readily available to any calls that you may have. And of course, we have our Facebook and YouTube site where this video can be seen again. And I know Melissa is recording it if you ever wanted to go back and look at it again also. So, but it's readily available. You'll also see some other videos, plastic repair, and a number of other courses that we've done with our friends at Impact. So in regards to iCar, there is an application that Melissa can send you. This is the application is directly from iCar, asking, for student information and all that wonderful fun stuff. This is really where the rubber meets the road. You'll notice here that they charge $57 for any class up to 8 hours, and they charge $114 for any class over 8 hours. And of course, right on the front page is where they're looking for your money. All of our courses are free. Even this webinar, as you know, is free. Here is a list of the courses. Matter of fact, if you decide to get credit for the course, I'm going to show you the test in a minute. Melissa can send it to you. Basically, they're asking for 45 days from this date, because we have to process your tests and send the scores to iCar. So then they ask you to send this application 45 days after you've taken the actual course. So here's the list of 13 courses that we offer currently. It's under our parent company, St. Gobain. You can see right here we did this metal bonding course. But we've done a number of other courses with our friends at Impact. I think we've done the body panel refinishing. I think we've done the adhesive refinishing. I know we've done the seam sealer course, I believe.
Yes, we have.
Great. So the one that we're doing today is the metal bonding one, which is right here. And like I said, it's almost like getting your transcripts or whatever. You've got to pay iCar to process the actual course. And you can see the other ones that are available. We're actually going to launch 3 more classes this year. Aluminum is creating quite a buzz. So we have an aluminum best practices course that they're reviewing right now as we speak. We also have another mother's course for their metering system, because that's gaining quite a bit of popularity. And if you're unaware, iCar has just added a new production manager's course. So we're adding a body shop manager and collision center best practice course that hopefully will be available soon once iCar gives us its blessing. So that application goes to iCar with your information once you've decided you want to go ahead and go for the points. And how the definition of training is the transfer of knowledge and skills. The only way we can tell that we transferred the knowledge and skills to anybody that's taken the class is they've got to take a test. And you can see on here what's the first thing that you do that we've covered in the class. Why do you need to clean the bond area? That's one thing. You notice Peter blew it off, but obviously best practices. If we clean it, we know we're going to get it good adhesion. And, you know, why do we need to go on the bind line? Why do we dry fit? A lot of the things that we've covered in the class are in this particular test, and if you're interested, Melissa can send it to you. So that's pretty much all I plan to cover today. Any questions, comments from any of our friends that are online?
I don't see any yet. Wow, that was much quicker than we thought.
Yeah, well, like I said, it's when you do it live, there's typically some more questions. Typically, you take a break in the class. You know, you usually have a little more interactive. It is nice that we at least have the video so people can see what we're talking about. And of course, you were nice enough to record it, so if we went too fast, people could go back and look at it again, I guess.
Okay, and I will follow up everybody who's on this webinar, guys and girls. I will send, you know, a copy of the test, a copy of all the information, what you'll need to do, Craig's information, so that if you do want to take the test, and what you do is submit it to Craig, and then he will see if you passed, and then if you did, you can submit it to ICAR with the, was it $57, I think, and get the 2 credits.
Yeah, just to elaborate on that, you need a passing grade of 70. I don't think we've had anybody fail. Even if you do, ICAR does give us the ability to let you retake it, so because you're paying your money, you should get credit for the course.
Okay, well, I don't see any questions. You were really thorough, and thanks, Craig. And again, we'll put this on our YouTube channel as well. Thanks, everybody, for taking time to watch this, and hopefully you'll get your 2 ICAR credits, and we'll let you know about future training opportunities. Thanks, Craig.
Thank you.